D-Wave's quantum computers are capable of solving several mathematical problem classes. One of the most important of these is the binary quadratic model. Many real-world problems can be formulated as a binary quadratic model, or BQM. A BQM is a special kind of equation that matches the structure of our quantum processing unit, or QPU. The QPU is made up of qubits and couplers connecting pairs of qubits. We can think about those qubits as variables in an equation, and the couplers as pairs of variables that are multiplied together, making up a quadratic equation. A lot of problems in a variety of industries can be easily mapped to BQM forms. For example, routing robots around obstacles in a warehouse, or choosing the best locations to build antennas. There are many real-world problems that have been run on D-Wave's quantum computers, and you can explore many of them at dwavesys.com/applications. In a binary quadratic model, the variables are binary. Binary means that each variable has two possible values. The Ocean SDK allows us to use either 0 and 1 for these values, or -1 and +1 in our BQM. When we write a BQM using 0 and 1 for our binary variables, we call it a quadratic unconstrained binary optimization problem, or QUBO. This form of a BQM is used a lot in math and computer science problems. On the other hand, if we use -1 and +1 for our binary variables, it's called an easing or icing model. This form of a BQM is used often in physics problems. Both QUBO and icing are types of BQMs, and we can map our problems to either model. Mathematically, they're equivalent, and it's pretty simple to switch back and forth between the two models. In fact, our Ocean SDK software is able to translate them for you. Let's look at a small problem of routing trucks to a set of cities. Each of these 4 cities needs to be visited by at least one truck. The trucks have these routes assigned. Truck 1's route visits cities B and C. Truck 2 visits cities A and C. Truck 3 visits cities B and D. And Truck 4 visits cities A and D. We can summarize these routes in a table as shown here. Which trucks should be used for deliveries? We want to use as few trucks as possible to be efficient. This problem can be modeled as a BQM. Here is a BQM with 0, 1 values, or a QUBO model that describes our problem. For more information on how to create a QUBO from a word problem, check out our problem formulation guide that's linked in the video description. Here's some code that runs this QUBO equation using D-Wave's Ocean SDK. One solution that might be returned is 0, 1, 1, 0. This string of zeros and ones encodes the answer to our question. Our binary variables for trucks 1 and 4 are assigned a value of 0, which means don't use this truck. The binary variables for trucks 2 and 3 are assigned a value of 1, which means we should use this truck. Some problems might have many different solutions, and so we may ask the QPU to return a collection of solutions, or samples. Using trucks 2 and 3 for this set of cities and corresponding truck routes gives us an efficient solution that uses just 2 trucks to visit each city exactly once. Thank you for tuning in to learn more about how to use D-Wave's quantum computers in the Ocean SDK. Check out some of our other videos to learn more about how you can start developing quantum applications today with our Leap Cloud platform.